Hi, welcome to another Level 1 Charts and Data video. In this video, we're going to talk about dot plots and box plots. Now, dot plot is a graph that's used to collect and display data with dots. Here's an example of Mr. Brown's mathematics class and the number of siblings of each student. They're very useful when we want to compare two sets of data side by side. A box plot is a statistical graph that plots the following statistics: the lower quartile, the lowest value, the lower quartile, the median, the upper quartile, and the highest value, all on the same graph. They're very commonly called box and whisker graphs. And they are also very useful when we're comparing two or more sets of data at the same time. Here's an example of a box plot. In this example, we've got Mr. X's algebra test results. Right, let's recap box plots. We have our lowest and our highest values. We have a lower quartile and an upper quartile, and the line in the middle is our median. Now there's 25% of data in each section, a quarter of the data in each section. In this section, 25%. In this section, 25%. So why is this section longer? That's because the data is spread out. The data is all spread out in this section, whereas in the third quarter, the data is really crammed up and close together. This middle 50% is made up of what we call our interquartile range. Our upper quartile subtract our lower quartile. Right, well, we quite often like to put dot plots and box plots together when we do statistical analysis. And I'll talk to you why that's useful. Because not only will we get to see what the lowest, the lower quartile, the median, the upper quartile, and the highest value is from our box plot, but we get to see other features in the dot plot. Features that you need to be aware of, and let's go through some right now. Whether it's a uniform or symmetry distribution, whether there are gaps, whether there's an outlier, whether it's bimodal, which means there could be more than one peak, or whether there's skewness. In this example, it's skewed to the right, so we have a tail or scattering of dots to the right, the tail. And this is skewed to the left, some tail, some dots going off to the left. So those are some important key features that you need to be familiar when you discuss dot plots and box and whisker graphs. All right, well, we're going to sum up this video by looking at the three cases of scenarios when we draw a conclusion with box plots. Here's case A. The boxes of each sample overlap each other and both medians lie within the box of the other sample. So you can see here an example with a sample, the blue, from the population of Group A, and the green is a sample from the population of Group B. You can see that the two medians hit each other's boxes and the two boxes overlap. Now, just because the green, the Group B median is larger than the Group A median, we cannot make a conclusion because they overlap. So here's the conclusion we have to say. We cannot make a conclusion that back in the population, the items from Group B are larger than the items in Group A, because both the medians lie within the middle 50% of the other sample and the boxes overlap. Well, here's case B. There is some overlap between the boxes of each sample, but one or both of the medians lie outside of the box of the other sample. And this is the conclusion we'd make in this case. We can conclude that back in the population, the items in Group B are likely to be larger than items in Group A, because although there is some overlap with the boxes, one or both medians lie outside the boxes of the other group. In our last case, the boxes of each sample do not overlap with each other, both medians lie outside the box of the other sample, and we'd write a conclusion similar to this. We are confident that back in the population, the items in Group B tend to be larger than the items in Group A because the boxes do not overlap and both medians lie outside the other box. Right, thanks for watching this video.